Hello friends, this lesson is about numericals on work transfer. Let us revise all the concepts which we have learned earlier in this particular topic. But before proceeding any further, I would like to introduce myself. My name is Harshit Agarwal, graduated from NIT Nagpur in 2008. I have cleared the Indian Engineering Services Examination and GATE examination. I have got the offer letter from most of the Maharatna and Navratna companies. Regarding course fee, there is no course fee as such, but your contributions are always welcomed. So to start with the very first numericals on work transfer, the numerical says a spherical balloon of 1 meter diameter. Keep in mind the diameter of balloon, which is 1 meter, contains a gas at 150 kilopascal. The initial pressure of gas is 150 kilopascal. The gas inside the balloon is heated until the pressure reaches 450 kilopascal. Now the gas which is inside the balloon is heated until the pressure reaches 450 kilopascal. The initial pressure is 150 kilopascal and the final pressure is 450 kilopascal. During the process of heating, the pressure of gas inside the balloon is proportional to cube of diameter of the balloon. See, the initial pressure is given as 150 kilopascal and the final pressure is given as 450 kilopascal. And one more condition is given as the pressure of gas जो है गैस के अंदर जो प्रेशर बैलून के अंदर जो प्रेशर है वो proportional a cube of diameter of the balloon, and we have to find the work done by the gas inside the balloon. So to start with, simply write the equation which is P is directly proportional to d cube, because it is written that the pressure is directly proportional to the cube of diameter, which we can also write as pressure is equal to K times d cube. So work transfer is equal to integral P dV. Work transfer is equal to integral P dV, and pressure is equal to K times d cube. So we can write work transfer is equal to integral K d cube dV. We know that pressure is directly proportional to d cube, so we can also write it as P1 is equal to d1 cube, which is equal to P2 by P1 is equal to d2 by d1 whole cube. Initial pressure P1 which is given as 150, final pressure P2 which is given as 450. So we can write d2 upon d1 whole cube is equal to 450 upon 150. That means d2 by d1 is equal to 1.44. That is d2 is equal to 1.44 because d1 is given as 1 meter. So with the help of P2 by P1 we have found final diameter. Initial diameter 1 meter, final diameter 1.44, initial pressure P1, final pressure P2 which is given. Simply start this numerical with dw equal to integral P dV, because we have to find the work done, and work done, it is a closed system, we have to find the work done is equal to integral P dV. So we will start with, first of all we have to find the value of K as well. So P1 is equal to K times d1 cube. The value of K would be 150 upon 1 cube, because P1 pressure is given as 150 and d1 is given as 1. So the value of K is 150. Also we know that the volume of sphere is 4 by 3 pi r cube. 4 by 3 pi r cube is the volume of sphere. It is a balloon, it is a spherical balloon, right? So 4 by 3 pi r cube, we can also write it as 4 by 3 pi d by 2 whole cube, which is 4 by 3 pi d cube by 8, which is pi d cube by 6. So this is the volume in terms of diameter. We have to find change in volume because work transfer is equal to P dV. So dV is equal to pi by 6 into 3d square dd. Change in volume is equal to pi by 2 d square into change in diameter. So work transfer is equal to pressure into change in volume. Pressure, we also know that pressure is equal to K times d cube, which is P is equal to K d cube into change in volume pi by 2 d square into d. So integrating it from d1 to d2, d1 is 1 meter and d2 is 1.44. So from 1 to 1.44, K d raised to power 5 pi by 2 change in diameter, K pi by 2 d raised to power 6 upon 6, which is from d1 to d2, which is 1 to 1.44. So K pi upon t 2 into 6, which is 1.44 into 6 minus 1 raised to power 6. So the work transfer is, well, value of K we have already found, which is 150, pi is 3.14, 2 into 6, which in bracket 1.44 raised to power 6 minus 1. So the work transfer in this particular numerical is 314.15 kilojoule. Please go through this numerical because this is very important. What we have done over here is that we have simply applied the concept work transfer is equal to integral P dV. Change in volume we have found in terms of diameter, and pressure we have written in terms of diameter, which is equal to K times d cube. Next is the second numerical, which is a system undergoes three processes. There is a system which undergoes three processes. 1 to 2 is isobaric process, 1 to 2 is isobaric process, 2 to 3 is a polytropic process with n equal to 1.4, 2 to 3 is a polytropic process with n equal to 1.4, and 3 to 1 is a isothermal process in which PV is equal to constant. 3 to 1 is a isothermal process in which PV is equal to constant. Two things are you have to find here. First one is find the volume at point 2 and second is net work transfer. To calculate the net work transfer, you have to find the inside area of this particular cycle. The inside area of this particular cycle, you have to calculate the net work transfer and change and value of V2 you have to find. So how you will proceed in this particular numerical is that from 3 to 1 is a constant isothermal process. So we can write PV is equal to constant. So we can also write P3 V3 is equal to P1 V1. P1 is given as 400, P3 is given as 100 and V1 is given as 1. So we have found V3, V3 is 4. See, you cannot find the value of V2. आप V2 की वैल्यू तब तक फाइंड नहीं कर सकते जब तक आप V3 की वैल्यू नहीं निकालोगे. And the value of V3 comes with process 3 to 1. So V3 is 4 meter cube, right? And from 2 to 3, 2 to 3 is a polytropic process and the polytropic equation is P2 V2 raised to power n is equal to P3 V3 raised to power n, and P2 is 400, V2 we have to find, P3 is 100 and V3 is 4. So the value of V2 is 1.486. Value of V2 is 1.486. So P1 and P2 is equal to 400 and P3 is equal to 100. V1 is equal to 1 meter cube and V2 is equal to 1.486 and V3 we have found it as 4. So these are the three values which we have calculated in our for the first part. Now how to calculate the work transfer. वर्क आपको पता है किसी भी कर्व को वॉल्यूम एक्सिस पे प्रोजेक्ट करोगे तो वर्क ट्रांसफर देगा, ये मैं ऑलरेडी बता चुका हूँ. सो सिंपली प्रोजेक्ट प्रोसेस 1 to 2 on this, process 2 to 3 on the volume axis and subtract process 3 to 1. You will get the net work transfer. So process work transfer from 1 to 2. Work transfer from 1 to 2 is equal to PdV. Pressure is given as 400 and change in volume V2 आपने कैलकुलेट कर लिया 1.486. तो वर्क ट्रांसफर फ्रॉम 1 to 2 is 194.4, which is what? Which is the complete this area rectangle. Similarly वर्क ट्रांसफर फ्रॉम 2 to 3, आपको पता है पॉलीट्रॉपिक प्रोसेस में वर्क ट्रांसफर कैसे फाइंड करते हैं, which is P2 V2 minus P3 V3 upon n minus 1. ये सारी वैल्यूज आपको पता है. Just put the values in this particular formula. You will get the work transfer from 2 to 3, which is 486 kilojoule. For work transfer from 1 to 2 is 194.4 kilojoule and work transfer from 2 to 3 is 486 kilojoule. Next you have to find the work transfer from 3 to 1. Work transfer from 3 to 1 is P3 V3 natural log of V1 by V3. P3 V3 natural log of V1 by V3. P3 is 100, V3 is 4 natural log of V1 by V3. So work transfer from 3 to 1 is 554.517 kilojoule. See, this is towards right, this is towards right, this is towards left. You have to simply see this is already negative, don't make it minus minus plus, and the net work transfer would be 194.4 to 486 minus 554.5. So the net work transfer is 125.88 kilojoule, which is this inside area. अगर मैं आपसे ये पूछूं whether this cycle is work producing या work consuming, अगर आपको simply ये बताना है क्या ये cycle work producing है या work consuming है, सी ये पता चलेगा. अगर work transfer की value positive आ रही है, if the value of work transfer is coming as positive then it is work producing, if it is coming as negative then it is work consuming. लेकिन तो एक शॉर्टकट तरीका है, अगर ये साइकिल क्लॉकवाइज डायरेक्शन में चल रहा है, if the cycle is going on in a clockwise direction then it is a work producing, and if the cycle is going in an anti-clockwise direction then it is work consuming. As you can see in the figure, it is going on in a clockwise direction, then it is work producing. So net work in a cycle is equal to area of closed region on PV diagram, and all anti-clockwise cycles on PV diagram are work producing or power producing cycle. So just go through these two numericals. These are very important. If you find any problem, please ask those problems in the comment section. I'll be answering your queries. Thanks a lot from my side. All the best. This is Harshit Agarwal.